What's up, everyone? This is Dariusz Kalbarczyk, co-founder of MG Poland, JS Poland, AngularMaster.dev and WorkshopFest.dev. Welcome back to Angular Master Podcast. Today, together with Kara Erickson, who works as a TLM of Aurora team at Google Chrome, former Angular technical lead, we will talk about optimization. I am also pleased to announce that Kara will be one of the speakers at this year's NG Poland conference. We will provide more details shortly. Hi Kara, how are you?
Good, how are you?
Thank you. Okay, so for those who don't know you yet, please tell us about yourself.
Well, I'm Kara Erickson. I live and work out of San Francisco, California. I am a senior software engineer at Google. I've been working there for 6.5 years now, and I'm now working on the Google Chrome team, specifically on a project called Aurora.
I see. Let's talk about the Aurora project then.
So the Aurora project is a Google Chrome project. So obviously, as a browser vendor, Chrome has invested quite a bit in the web. We want the web to be successful. So it's really important to us that the web ecosystem is healthy and thriving and fast because we want it to be accessible to everybody. So in the past, Chrome has tried to reach developers more individually through outreach, educating about best practices, writing blog posts, that type of thing. And that has been somewhat successful. However, that approach can be limited sometimes because if you're reaching individual developers, even if they know the best practices and they want to incorporate them, organizational priorities don't always make that possible, right? Because you also have business priorities and the web is also changing really fast. And so it's, even if you do know the web best practices, like they might be different in a few months. And so it can be really hard to keep up with like the latest and greatest browser features. So we know that a majority of web developers out there are using web frameworks at work. So the idea of this project is rather than trying to reach developers individually, instead, we work with open source web frameworks that the majority of web developers are already using and bake best practices into those web frameworks and try to focus on setting strong defaults. And that way, even if your organization doesn't really have the time to invest in performance, or even if they don't know what the best thing to do is for performance, just using the web framework is enough for them to be successful. So, so functionally what that means is that we collaborate with framework partners. We work with like Angular and with Next.js and with Next and other frameworks to make this happen.
Awesome. But why Google is investing in this space?
It's important to us that the web is actually fast. So performance is one part of developer experience. In general, it's important to Chrome that people use the web, people enjoy using the web, right? And so we want to focus on developer experience on the web. And so the first thing that we are focusing on for developer experience is performance, because that's a big part of it. So the reason that they're investing in my team is that our team can help the performance and the developer experience on the web by focusing like kind of in the right place, if that makes sense.
Yeah, it makes sense. Well said. Let's back to Aurora. So what it means that a collaboration between Chrome and open source web frameworks and tools.
Yeah, so functionally what that means is we have certain framework partners. So, Angular, for example, and there's a few different kind of levels of partnership. So with Angular historically, we've had more of a consulting role in that, we consult with them about performance best practices and what, how to make sure that the framework is doing what the web platform recommends. But this year, we're really excited because we've kind of decided to do a deeper collaboration together. So what that means is direct code contributions from our team. So rather than just consulting, we're also actively contributing code to Angular and like helping experiment with partners. And we're very like deeply involved in all these projects. So yeah.
As a big fan of Angular, I have to ask you how Aurora connect to Angular. This is the most important question for today.
Yeah. Well, as I was saying, you know, we're trying to work with them more this year. So if you look on Angular's public roadmap for this year, you can see that there's some Aurora projects on there. Specifically, the ones that we're involved in are things like image optimization, improving like the loading of your images on your websites. We're also working to improve the Angular story for server-side rendering and hydration, because that's an area that's been kind of, I don't know, underinvested in historically. And we're starting to talk about other efforts that could be good for performance for Angular, like the loading strategy for third parties, because that can be a big performance bottleneck, and also how we can improve change detection to be a little bit more performant and understandable.
So how can we use this Aurora knowledge to optimize Angular app?
Well, so when these projects complete, like the best thing you can do is try out the things that we build. So when the image directive is actually available, you know, you can try it out, and hopefully that will boost your performance numbers. But I mean, in the meantime, I can give you some general advice, like performance advice. Is that kind of what you're looking for? Or?
Yeah, definitely.
Sure. So I guess the first thing would be, you know, if you're not already benchmarking your website and looking at your core web vitals, I think obviously that's a great place to start. I would run your website through webpagetest.com. I think that's one of the best tools out there. Also, of course, there's Lighthouse, which is fantastic, and Chrome DevTools, also fantastic. But regardless, like you want to have some sort of lab-based analysis as a basis for as a baseline before you start actually trying to change things. And then also, if your site is in the top, I think it's like 4 million origins, you also have access to the Chrome UX report, and that will give you field data as well in addition to lab data. So that's like, rather than one specific run, like what happens, you know, if you run your code on your machine one time, which is what a lab test is, the field data will tell you what your actual users are seeing in aggregate, and that can be also really helpful. So, so once you have all these numbers, you can figure out, okay, which core web vital is the site struggling with, if any, and then that's kind of a great entry point for you to figure out like what optimizations you should be doing. So, I guess an example. So, like, let's say your site doesn't have great LCP. So LCP, I think, as you may know, is largest contentful paint.
Yeah.
And so you want that to be, you know, as soon as possible so that users see something useful on the screen. So if your site didn't have great LCP, the first things that I would check would be things like, you know, is your app using server-side rendering or Angular Universal? Because rendering on the server is a great way to, you know, present something as quickly as possible to the user. I'd also make sure that if you have images on your page, that you know which images are your LCP images, because the majority of LCP elements tend to be images. And so if you know which ones are your LCP images, you can optimize them. So you can add preload tags or pre-connect to the image origin. And Chrome also just released this feature called priority hints, where you can even set the priority on the image tag itself to high to make sure that it loads super fast if it's the one that's going to be, you know, the most important to the user. And then kind of along the same lines, for images that aren't visible right away, you want to do the opposite, right? So images that are below the fold, or if they're hidden by like a carousel or something, you want to lazy load those. But yeah, I mean, there's I can go on and on, I guess, about different optimizations, but I guess like the big point is make sure you're measuring your core web vitals and using those tools. And then there's so much low hanging fruit that we see from tracing sites out there. But long term, what we want to have for Angular and for other frameworks is to have these features built in so you don't have to check this and check that and then check this and then check that. Just using the framework should be enough. So.
Okay, awesome. What are the performance issues your team focuses on? Can you tell me more about the Angular image project and what it aims to address?
In terms of what the team focuses on, I guess I'll start with that question. We have a few main areas that we're focusing on right now. So one is obviously image optimization, as I was just going on and on about. Another one is script loading. So a huge issue that we see across the web is that people are, adding third-party scripts to their websites, and those third-party scripts are either, being loaded too quickly or at the wrong time and they block rendering, or maybe, there's just quite a lot of third-party code, and so then you end up with a giant amount of JavaScript that's being run. So our second big focus is, trying to figure out how we can work with frameworks to get a better experience working with third parties so that you don't, accidentally shoot yourself in the foot. So that's another big area. Other things that we work on, fonts is another big area for, performance bottlenecks. So if you're, 70% of the web, something like that, is using Google fonts, but it's surprising when you have such a big, swath of the web using something, but, you see that a lot of people are still not using best practices for it. So I guess an example of that would be, you should be preloading your fonts where you can. You should be trying to, inline the font, some of the font style sheets so that you're not making more than one request when you don't need to. I guess other areas are, making sure there's not font related CLS. If you're switching to a font fallback, if your fallback font is a completely different size than your web font, then you see some layout shift, which isn't great. So I guess, image optimization, third party code, fonts. I'm trying to think. And then there's also just rendering in general. So server-side rendering and hydration and that whole story of
Exactly.
So your second question was about the Angular image project.
Yes.
So basically that directive is trying to address some of the common issues that we see with image optimization. So as I was talking about before, you should really be lazy loading images more aggressively. So obviously you don't want to lazy load your LCP image, but anything that you don't see right away should probably be lazy loaded. So we're building a directive. That's kind of what this image project is, like the core solution of it. And so the directive will lazy load your images by default because, most of your images should be lazy loaded. And then you can kind of let us know which image you think is your LCP image and opt it out of lazy loading. But it kind of gives you, the right behavior by default. And then for, the special case, which is your LCP image, there's an opt out. And the directive will also warn you if you're doing things that we know will de-optimize your performance. So if you're doing things like, so if you mark your LCP image and you're not preloading it or pre-connecting it, we know that you're not doing as much as you should be doing to get that to load quickly. So we'll, show you a warning for that. We can also warn you if you're not sizing your images. So if you don't have the width and height attributes, that's a big no-no because then you're going to get into that situation where, the image loads and your whole layout shifts down and, you click on the wrong thing, which is always really frustrating. And eventually, we plan on kind of expanding the feature set. So the first version of the image directive might be pretty lean, just focusing on loading. But we also want to move into areas like supporting responsive images. So one thing that we see all the time is people either not setting source set and sizes to serve the right sized image for the device, or even if they're doing that, they're setting the sizes attribute incorrectly because the syntax is actually kind of hard to get right if you don't know what you're doing. So what could be really cool is if the image directive handles that for you. So if you give us, some basic configuration information about what you're trying to do, it can set source set and sizes for you. I guess it's also worth noting that in addition to these projects with frameworks, we're also kind of using these experiences building with frameworks to inform or to kind of create a feedback loop between frameworks and the web platform itself. So, I'm talking about, we should set source sets and sizes for you because it's like kind of difficult and confusing to do on your own. As soon as we start doing that, we're just, we should talk to the Chrome team that's responsible for this and see if there's something we can do on the platform to make that easier. So that's kind of like the second big part of our role.
Okay, so next question is, what is INP, the interaction to next paint?
So INP is a new experimental metric that just came out. It's just announced. And it's not a core web vital yet. It's not. LCP, CLS, and FID are still the three main ones.
Okay.
But it's an experimental one that we are starting to test. But I could tell you a little bit about what it measures, if that's helpful. So you can kind of think of it as an extension of first input delay, if you're already familiar with first input delay or FID. The difference is that...
What is difference, yes, exactly, between this INP and FID?
So with first input delay, it measures specifically input latency. So what that means is it starts measuring when the user interacts with the page, and it stops measuring when the main thread is available enough to start running the event handlers. So but there's a few things that happen after that before the user actually sees anything. So if you think of the whole timeline from the user interaction to when the user actually sees something painted on the screen, input latency is only a part of that duration, right? Because it stops when the event handlers are able to run. But then there's also, the processing time of the event handlers, and there's also the delay between when the event handlers run and when a frame can actually be presented to the user. So, processing time and presentation delay are not a part of first input delay. However, interaction to next paint takes the whole duration into account. So you can think of it as kind of like a superset of first input delay. So it's input latency plus processing time plus presentation delay. So it's a lot more like broad in its scope, just in every interaction. And first input delay also just measures the first input delay. And interaction to next paint takes, again, a broader view. So it looks at all the interactions on a page until the user leaves the page. And it picks one of the worst latencies that can be measured out of all of those. So those are the main differences.
Okay, so why INP is relevant to frameworks and how Aurora and frameworks are working to optimize responsiveness?
So, when you are thinking about interactivity, mostly websites will use JavaScript to implement the interactivity on their website, right? So anything that is JavaScript focused is going to be relevant for INP. And web frameworks, as we know, tend to be pretty dependent on JavaScript. So frameworks have a lot to do with the types of things that will affect INP. So some examples would be event handlers. Frameworks often will wrap event handlers with their own logic. So an example is like Angular does this. If you write an event handler, Angular will wrap it to do things like marking views dirty for on-push change detection. And so the way that the framework handles wrapping event handlers, like how much overhead it adds, is super relevant because, of course, unlike FID, INP measures event handler duration. And also frameworks tend to be more involved in how scripts are loaded, more opinionated about it. So since third-party code is also a huge part of JavaScript execution, how the framework handles third-party code, how the framework handles things like code splitting, they're all relevant.
What other frameworks are you working on?
Like in addition to Angular?
Yes.
We also work fairly closely with Next.js. Historically, that's actually been our main collaboration because we have a bunch of features in Next.js that have come out. For example, to handle like third parties in Next.js, we already have a solution. It's called the script component. And if you use the script component in Next.js, it will make sure that your third-party script doesn't block rendering, which is pretty great. And it also has like integrations with party towns so that you can, defer your script to a web worker, a bunch of experimental stuff like that. And Next.js also has an image component, which is kind of similar to the image directive that we're working on with Angular. So kind of a lot of the same ideas with Next.js. And then lastly, we are working with the Next team in the Vue ecosystem. And that collaboration is kind of just like starting to take off. So there's a lot to come there.
How does JavaScript affect INP?
So I guess the main thing that you would need to think about is, how JavaScript is being processed on the main thread and how much JavaScript is being processed. So I guess both FID and INP are concerned with the availability of the main thread, right? Because that's what causes latency. But unlike FID, INP has some additional concerns. So I think I mentioned before, event handlers, right? So if your framework has a bunch of event handler overhead, that's something you need to think about. If how your framework is doing hydration is also really important because hydration is usually a fairly heavy JavaScript activity. And so how efficient it is at that is really going to affect your rendering and how much the main thread is blocked. I guess a good example of, how frameworks are trying to tackle this is, with React 18 and its server side or, its server components, right? They're trying to break up hydration so that, individual components can hydrate in smaller chunks. So that's kind of an example of a mitigation there. But even outside of frameworks, application developers should be looking at, do you have really heavy event handlers? Are you like doing a lot of intense computation in your event handlers? Do you have a lot of event handlers? Are you looking at, heavy things like scroll? Do you have inputs that have focus handlers and also, key down and key up and, that kind of thing. And then I guess there's also the usual suspects that block the main thread. So, if you're not optimizing your JavaScript because you're not using code splitting or lazy loading, like you just have one monolithic JavaScript file, obviously the longer your script is, the longer it's going to take to complete. And then, as I keep coming back to, obviously third-party scripts can be problematic as well because especially since you're not in direct control of it, they can set event listeners for you. So maybe your third parties have really extensive event handlers that you don't know about. And, they might be running at weird times, to block rendering. So yeah, no, there's plenty of ways that JavaScript can affect INP.
Okay. How Aurora and Angular addressing INP issues?
Yeah, that's a great question. So we are actively starting to address these issues. So part of the roadmap that we have with Angular this year is specifically meant to target INP issues. So the best example of this is probably the hydration project. So I can tell you kind of like a high level. We haven't done any real design yet, but I guess the idea is if you're using Angular SSR, it doesn't really have what you would call real hydration, right? Because the idea of hydration is kind of that you would take the existing DOM that was presented in SSR, right? So you already have all of your DOM elements presented. And then the framework would go in and kind of, negotiate their data structures with the DOM so that they are in sync, right? So it's just kind of like matching your framework state to what state you created on the server when you initially rendered. That's how hydration is, typically works. But with Angular, I think that part was never really built. So it's destructive. So when you use Angular SSR, it'll present the DOM to you, like the fully rendered DOM, But then on the client side, rather than hydrating, it will just like destroy the DOM and start over. So it's not really real hydration, and so it's a little bit more heavy than it needs to be. So the idea is trying to figure out how to turn it into more traditional hydration. And then also there's a bunch of, low-hanging fruit in terms of usability for SSR, just because a lot of websites aren't using it because there's some things that are a little more difficult to use. Sorry, so to get back to your, initial question, improving hydration is a really big part of improving IMPs. So that's what we're working on with Angular. We're also planning on exploring improvements to change detection because, it's kind of easy to shoot yourself in the foot with change detection if you don't know what you're doing. Like if you're not using on push, if you have a bunch of event handlers, especially with third-party libraries, and you're not running them outside the Angular zone, there's a bunch of ways that you can make change detection kind of run all of the time, which will block the main thread. So we're trying to figure out how to improve that.
Okay. In October at NG Poland conference, you will talk about how Angular, or more precisely, its new directive, deals with the optimization of image. What else we can expect?
Well, I think at the conference, I will mostly be talking about the image directive directly. But in terms of other projects, I guess the hydration project, the change detection project, those are fun things coming up. But I think we'll only be talking about image optimization at the conference. So.
Perfect.
But who knows? Maybe something else will come up.
Yeah, yeah, exactly. It was my last technical question. I have one more.
Sure.
One book you can recommend to our listeners. It can be technical or non-technical.
Ooh, non-technical too.
Yeah.
Oh, that's great.
Why not?
Okay. Can I do both? Can I do a technical book and a non-technical book?
Perfect.
Okay, cool. I feel like I'm cheating, but so for the technical book, oh man, there's so many really good ones out there. I think the most recent one that I read and really liked was Responsible JavaScript by Jeremy Wagner. He also works on Chrome. He's a really smart guy. It basically gives you the latest and greatest performance advice if you're working in JavaScript. I really think everybody should read it. It's fantastic. Also, Adi Osmani just published a book about web development. I can't remember the name. I'll have to look it up. But that's another one that I just read that is also amazing. So I think those would be my top two technical recs. For non-technical, I'm a big fantasy fiction nerd. So I would say if you haven't read Brandon Sanderson, I would highly recommend the Stormlight Archives series by Brandon Sanderson, but it's also a very popular series. So
yeah.
Possibly already read it, but
perfect. So thank you so much for today's conversation. And I'm looking forward to see you at NG Poland.
Yeah, that'll be so fun.
Yeah, exactly. One more time, thank you so much.
Thank you.